Okay, hello Integrated Science, this is Mr. B, and I ended the last video saying that it would be your last one unless something crazy happened, and apparently something crazy did happen, which is me forgetting that there was in fact one more section after this. So, Section 5, the expanding universe. So, sorry about that for giving you a little bit of false hope, but these will be our last two videos of the year. Again, double check this time. So, um, for the expanding universe, you're going to have to think back to some things you've learned in the past to kind of help this section make some sense. So, absorption lines of a galaxy shift toward the blue end of the spectrum when it moves towards the Earth, and then the lines shift to the red end of the spectrum when a galaxy moves away from the Earth. So remember that all visible light actually exists in the different wavelengths of light. Again, red, the Roy G. Biv. Again, there's red, orange, yellow, green, blue, indigo, violet. All of those colors of light go into making up the white visible light that we see. So galaxies will emit different colored lights, and we will notice that as galaxies move away from us, they appear to be more red, and as they move towards us, they appear to be more blue. So I will try to explain this as best as possible using, again, hopefully some past information that you might possess to kind of help this make a little bit more sense again. Okay, yeah, so we'll get into that more in a second. So um, they just kind of give you just kind of some more introduction thing to kind of hit you really hard there at the beginning there with that big overlying thing, but they don't really explain it yet, but we'll get back to that in a moment. So when you observe a star that is 10 light years away, you are seeing the star as it was 10 years ago because light took 10 years to travel from that star to Earth, which makes sense. A light year, again, how long does it take light to travel in a year? Again, something's 10 light years away, that means you're seeing light that's 10 years old. Images of galaxies that are billions of light years away show how those galaxies looked billions of years ago. So again, we can kind of tell, again, depending on how far away they are, we can either tell maybe how recently they look, or again, how much they've changed recently, or again, billions of light years away can maybe show what that probably looked like, and that galaxy looked like at its early formation. So all of this kind of, again, galaxies moving, again, appearing and what their appearance is to be. The reason why we care about that is because the fact that galaxies are either mostly moving away from us, it shows us that the actual universe itself is expanding. And the reason why we know that is because the red shift that, again, I introduced early on, but again, we'll explain more, in the spectra or spectrum of galaxies show that the universe is in fact expanding. So the fact that the universe is getting larger, that will kind of give us a different interpretation on what color light we see being emitted from different galaxies. And to explain this, they introduced something called the Doppler effect, which we talked about this early on in the year, I believe, or sometime in your science past you've talked about the Doppler effect. But what the Doppler effect is, and it's usually used for sound. When you think of a police siren, when a police siren is far away, the sirens kind of almost, the sounds from the siren almost sound more far apart. It's almost like there's a, and then as they get closer, those sounds get a little bit closer together. So like, again, police cars coming from a long way down the road, it goes past you, then you can hear the sirens kind of having their more regular rise and fall, and then as they go away from you again, they have that longer shifts in between, like again, the rising and the falling of the siren of the sound. The same thing kind of works in visible light. So when a star or galaxy is approaching Earth, the lines are shifted to shorter, bluer wavelengths. So shorter wavelengths are blue. When it's coming to us, the wavelengths are not moving. There's not as much distance in between the wavelengths, so they appear to be blue. When the star in the galaxy is moving away from us, the lines shift towards longer wavelengths. So again, just as the siren, as there's more time in between the rise and fall of the siren as it's going away, red wavelengths kind of work the same way interpreting our eyes there. The red wavelengths are longer. They're not so much there's not so many rise and falls. The rise and falls are more spread apart, so that's when things are moving away, they appear to be red. So the larger the observed shift is, the greater is the speed. So I'll try to explain that more in class because there's kind of some visual hands-on things that might make a little bit more sense, maybe with the sirens there as well. But as galaxies moving away, they appear to be red. That's because it takes longer for the wavelengths to reach us. They're longer, again, as they're coming to us. It does not take as long for the wavelengths to reach us. Again, the shorter wavelengths are blue. And in the mid-1920s, this was discovered. It was discovered by a guy by the name of Edwin Hubble. You've probably heard of the Hubble Space Telescope, named after Mr. Edwin Hubble there. He discovered that the light from most galaxies undergoes a redshift. That is, their light is shifted towards the red wavelengths. And this showed that nearly all galaxies are getting farther away from Earth. If you're getting farther away from Earth, that means the universe itself is expanding. And he also found that the more distant galaxies, the ones that are farther away from us, have greater redshifts. So this relationship between the distance between the redshift there is called Hubble's law, and it says the speed at which a galaxy is moving away from us is proportional to its distance from us. So the farther away you are from Earth, that means the faster you're expanding. And to give it kind of some numbers to it, the most distant observed galaxies are moving it away at more than 90% of the speed of light. So and the ones the farthest away, again, moving much more quickly, and they actually do have some calculations for this, but I think we'll just end it, with this little comparison. We won't worry too much about the calculations. So to give a kind of simpler visualization for how galaxies move, they use raisins and a loaf of bread. So raisins represent individual galaxies or groups of galaxies, and the dough is going to represent the universe, and we'll see a picture of this in a moment. When the dough rises, the distance between the raisins increases, but the raisins stay the same. Again, in the same way, the most distant galaxies are moving away from us more quickly. So you can see right here, raisins, 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 and then as the universe is expanding, the ones that are, again, starting farther out, they move away at a much quicker rate. So again, the raisins and this rising bread dough are all moving away from one another as the dough expands, again, very similarly as galaxies move away from one another as the universe expands. So I believe that is it. Oh, no. The last thing, the space between the galaxies is expanding in all directions. Again, the universe as a whole is becoming larger. So not just one small portion of this bread is expanding, the entirety of the bread is expanding. The entirety of the dough is expanding, just as the entirety of our universe. Again, it's not just one area that it's expanding. The entire universe itself is in fact getting larger. Again, that red shift being the big example. And again, I'll try to explain that more in class to help it make more sense. But that's it for now for our second to last video. Let me know if you have any questions.